In this video, we're going to look at the solutions to Chem 102 of Imo State University 2019-2020 section. The first one says, draw the structure of the following compounds. 1. Benzene, cyclopropane, furan, thiophene, and naphthalene. So the first one, benzene, the simplest way to draw benzene is this way. Benzene. The second one is cyclopropane. That's 3 carbon atom. Cyclopropane. The third one is furan. Furan is this way. This is furan. The next one is thiophene, that looks like furan, just that here there is sulfur. Thiophene. The next one is naphthalene. Naphthalene is drawn this way. Naphthalene. So benzene, cyclopropane, furan, thiophene, naphthalene. So the next question says, an organic compound contains carbon 64.88%, hydrogen 13.51%, and oxygen 21.61%. Calculate the empirical formula and the molecular formula of the compound if the molar mass is 74 grams. Okay, so what we will do first of all is to put carbon here, since it contains carbon, hydrogen, and oxygen. So the first thing we do, we write out their percentage composition. This is 64.88%. Here, hydrogen is 13.51%, and oxygen is 21.61%. If you add all of them, you're supposed to get 100%. Okay, so the next thing is to divide them with their respective molar masses. Now, carbon is 12, so we have 64.88 over 12. Oxygen is 1, 13.51 over 1. Hydrogen is 1, then oxygen is 16, so we have 21.61 over 16. With our calculator, we can press, and here we'll get 5.4. And here still remains 13.1, no need for calculator, and here we'll get 1.35. So the next stage is to divide all through with the smallest answer gotten from here. If you look at, you'll notice that this is the smallest answer. So we'll have 5.4 divided by 1.35, here 13.5 divided by 1.35, here 1.35 divided by 1.35. Here already is 1, and here we're going to get 10, here we're going to get 4. What it means is that we have C4, and we have H10, and we have just one O. So this is the empirical formula of the compound. So since the empirical formula is C4, H10, and O. For us to now get the molecular formula, we put it C4, H10, O. And we were told that the molar mass of this compound was the molecular mass 74 grams. So it's equal to 74. What it means is that we will now have the molar mass of this is 12 times 4. Here is 1 times 10 plus 1 times 10 plus this is 16 times 1, so just 16 is equal to 74. So that we'll have the total answer here will be 74. 74n is equal to 74. So if we now make n subject of the formula, n becomes 74 over 74, which is equal to 1. What it means is that the molecular formula is still C, n is 1. Since n is 1, so all of them remains intact. C4. So here is molecular formula C for H10O. Peradventure, you solve a different question and you get that the value of n is 2. What it means is multiply n2 with the rest of them. So all of them, this one would have been 8, this will be 20, this one will be 2. So you use the value of n to multiply each of them. In this case, n is 1, so all of them multiplied by 1 remains the same. Now the next question was that to write possible structural formula of the compound and name it. Now this compound, for us to get a possible structural formula, it will be CH3 CH into CH3, then CH2 OH. C is 1, 2, 3, and 4. H is 3, 4, 7, 8, 9, and 10. So O is just 1. So if we were to draw it, it will look like this: C3, CH, and there is an attachment C, also H, 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 that's this. Then there is C, 2H, and then OH. So for us to name this now, it becomes 2-methyl, which means at the second carbon atom there is a methyl. 2-methyl, 2-methyl propanol, because 3, longest chain is 3, propanol, or you say prop1ol, because at the first carbon atom there is, that's where you see the alcohol group attached. Propan1ol, propan1ol. We use hyphen to join alphabet and numbers, and we use comma to join number and number. So since this is 1, this is another alphabet, we use hyphen. Number 2 question says, write the electronic configuration of the following elements with their atomic number and mass numbers. Mass as follows: oxygen 816, carbon, and so on and so on. So let's begin that. Oxygen, O, for us to write oxygen is 1s2, 2s2, 2p4. So the next one is carbon. To write carbon, 1s2, 2s2, 2p6, 3s2. So the next one is aluminium. The next one is aluminium. For us to write aluminium, aluminium is 1s2, 2s2, 2p6, 3s2, 3p1. For us to write nitrogen is 1s2, 2s2, 2p3. For us to write the next one, calcium. Calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. The next question, B, says indicate the type of hybrid orbital in the molecules. These are the molecules. So for this tetrachloride is sp3 hybridized. For this ethyne is sp hybridized. For ethene it is sp2. For methane it is sp3. The next question says define the term hybridization. Now hybridization is the mixing of atomic or orbitals, that's atomic orbitals of the same energy level in order to create an orbital with equivalent energy, known as an hybrid orbital. The next question says, define the following: carbonium ion, radicals, inductive effect, carbon anion. So carbonium ion, or what some call carbocation, that's cation, is a positively charged species containing a carbon atom having, for example, only 6 electrons in 3 bonds. What we mean by that is it looks this way. So this is a carbocation, or what some call carbocation, carbonium ion. The next one is a radical. Now radicals are species with at least 1 unpaired electron. 1 unpaired electron. That's what you have, something like this. 1 unpaired electron. The next is inductive effect. It is defined as an electron displacement effect that occurs due to the unequal sharing of pair of electrons in a sigma bond between 2 atoms of different electronegativity. Now we need to note that it is a permanent effect and it is affected by distance. The next one is carbon ion. Is a negatively charged species containing a carbon with 3 bonds and an unshared pair of electrons, which is like this, and it carries negative. The next question says, name and draw the 4 isomers of butanol. Now the first one, let's do that on a fresh page. The first one is the normal butanol, which is 1, 2, 3, 4. So the OH stays there. This is hydrogen. That's the normal. They say we should draw a name. So normal butanol. Or you can say but1O, butan 1O. The next one is actually this one. The next one is butan 2O. We'll say 1, 2, 3, 4. We come to the second, we give him the functional group. So butan 2-ol. So to show that the alcohol functional group is on the second carbon atom. The third one is 1, 2, 3. We now have OH. This one is 2-methyl. 2-methyl prop. The longest chain is 3. Prop. So propan 2-ol. To show that it's the second carbon atom. That's where the functional group of alcohol is. And then the last one is we have 1, 2, 3. Methyl group is here. So we have 2-methyl propanol, 2-methyl propanol or propan 1-ol, 2-methyl propanol or 2-methyl propan 1-ol. Number 4 says write the structural formula of 1, 2-dimethyl-propane, 2-methylpentane, 2,3-dimethylbutane, 1-bromo, 2-chlorocyclohexane, 1,3-dimethylcyclopentane, 3-bromo, 2-pentene. So the first one, 2,2-dimethyl, means first of all we'll draw the parent chain, propane. At the second carbon atom there is methyl. So 2,2-dimethyl. So 2,2-dimethyl propane. Second one, 2-methylpentane. We first of all draw the parent chain, which is pentane. 1, 2, 3, 4, 5, pentane. 2-methylpentane. At the second carbon atom, we'll add methyl. The rest is hydrogen. So the next one is 2,3-dimethylbutane. We draw the parent chain, butane. So they say 2,3-dimethyl. So it means at the second carbon atom there is methyl. At the third carbon atom there is methyl. Then the rest hydrogen. We can still do it this way. Put one methyl down. Put another methyl up. Still the same thing. The rest hydrogen. The same, 2,3-dimethylbutane. Then the next one is 1-bromo-2-chlorocyclohexane. We draw cyclohexane first of all. 1-bromo-2-chlorocyclohexane. Then the last one, 1,3-dimethylcyclopentane. Parent chain, cyclopentane. So we draw cyclopentane. 1, 3. So 1, 2, 3. 1,3-dimethyl. So there is methyl here. There is methyl here. Cyclopentane. The last one, 3-bromo-2-pentene. 3-bromo-2-pentene. So first of all, draw the parent chain, which is pentene. 5. 2-pentene. Second carbon atom, there is double bond on the second, 2-pentene. 3-bromo, it means at the third carbon atom there is bromine. So the rest is now hydrogen. 1, 2, 3, 4. This is complete. 1, 2, 3. We put here 4. So complete. Every carbon must have a maximum of 4 bonds to it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The next question says, draw the following cycloalkane, chair conformation of cyclohexane, both conformation of cyclohexane, staggered form of alkane, eclipse form of alkane. Now, the chair conformation looks this way. It looks this way. So we have hydrogen, hydrogen, we have hydrogen, hydrogen, we have hydrogen, hydrogen, we have hydrogen, hydrogen. So this is the chair conformation of cyclohexane. Then the boat conformation looks this way. So hydrogen at every point. So this is the boot conformation. The next one is the staggered conformation. Staggered conformation of ethane. That is this. The next one is eclipse. Eclipse, they are close. This is the eclipse. The next question says, what is the structural difference between the carbonyl carbon in an aldehyde and a ketone? So the structural difference there is that aldehydes possess a single hydrogen attached to the carbonyl carbon, whereas ketones always contain two hydrogen carbons. What I mean by that is that this is aldehyde, alkyl group, then hydrogen. This is aldehyde. While, let me write it in full. This aldehyde. While for ketone, its carbonyl carbon carries no. An alkyl group here is different from here. So this is ketone. So these are the structural difference between both of them. So the next question for propanone, we have 1, 2, 3. So this is propanone. Another name for it is acetone. Remember, H hydrogens. The next one is dimethyl ketone. Dimethyl ketone, still called acetone. Dimethyl ketone or acetone. The next one is pentanal. Pentanal, let's say 1, 2, 3, 4, 5. So the rest hydrogen. The next one, benzaldehyde. Benzaldehyde. Then the last one, pentantrione. Let's just use this pattern. 1, 2, 3. 1, 2, 3, 4, 5. So at the third carbon atom, you have double bond. This one is pentantrione. Another way. One carbon atom is here, carbon atom. So at the third carbon atom, that's where the double bond is, the functional group. And this pentantrione is a colorless liquid. It has the same odor as acetone. The next question says, name 2 reagents used to distinguish between aldehydes and ketone. So the answer is, we have Skipp's reagent, we have Phelan's reagent, silver mirror test, Toulon reagent, any 2. The next question says, what is an amine? Now, amines are alkyl or aryl derivatives of ammonia. And they are classified as primary amine when we have one aryl or alkyl group with the functional group of amine. This is the functional group of amine. We also have secondary when we have 2 aryl or alkyl groups with this, or just this secondary amine. Or we also have tertiary amine when we have RO3, then N, that's tertiary amine. So we have example is the simplest one, which is methylamine. We also have ethylamine, then amine, and so on. So number 6 question says, define the term esterification. Write the equation for the reaction between ethanoic acid and ethanol. Now, let's define esterification first. Esterification is the process of combining an organic acid. Is an organic acid with an alcohol. This is an alcohol, to produce esters and water. So it gives you esters and water. That's esterification. They now want us to write the reaction between ethanol and ethanoic acid. So we have CH3 COOH plus CH3 CH2OH. It will happen in the presence of concentrated H2SO4. So to produce ethyl ethanoate, which is and water. The next question says list 2 uses of esters. Now, esters are used as solvents for cellulose, gums, oils, and so on. The next one is also used in the making of artificial flavors. The next question says name the following compound. This is ethanoic acid or acetic acid. This is propanoic acid. 1, 2, 3. Propanoic acid. This is pentanoic acid. 1, 2, 3, 4, 5. That's pentanoic acid or valeric acid. That's the common name, valeric acid. Then this 1, 2, then 8. This is and this is phenyl, and this is phenyl acetate. So this is phenyl acetate. This is benzoic acid or benzene carboxylic acid. So that's this. So feel free, click the subscribe button to my channel if you have not. Leave your comment in the comment section. Thank you. Remember to share it to your friends. Thank you.